Got to give the people, what they want. Yeah, you're gonna hear a lot of that. So in any case, you're gonna write all of this stuff down in your notebook. You're pretending like Bass or Tillis is giving you notes to take in class, live and in person. So when you bring the homework back next class, which I believe will be on Friday, you will have this in there and be like, hey, open up your notebook, have it on your desk, I'm gonna check it off to make sure that you did it, okay? So this is easy, all right? Pause and get this written in your notebook. Cool, you should have just did that because you're in Algebra 2 Honors and you're smart and you can figure that out. So, recursive rules are a rule that explains a sequence where each term is found by doing something to the previous term. So like if I have a recursive rule, like let's say my first number was, let's say 7, and I say the rule is plus 3, then the next term would be 10, plus 3, 13, plus 3, 16. That's a recursive rule because you always just do something to the term that came before it. All right, so let's get this part down. So we're going to talk about previous term, current term, and next term. All right? So let's actually use that. So let's say our current term was 7, and our rule was plus 3. So the next term, obviously, you should know would be 10. The previous term would be 4. This should make sense. So this is a sequence that could just keep going on and on forever. Okay? So now, this might be the 7th term, right? So this could be A sub 7. And I'm just saying the current term is A sub 7. It's the 7th one, but that's where we're at right now. So that's current. That's where we're starting. This is the 7th in a line of terms, okay? So that makes the next term, if this is A sub 7, what do you think the next term is going to be? That's right, you're really smart, you figured it out. That would probably be A sub 8, which makes the previous term in this particular situation A sub 6. I'm just checking to make sure you can see all of this. Yes, you can. Okay? So, right? These are our terms. We happen to be on the 7th term here because I just started in the middle of the sequence. So this is A sub 7. The next term is A sub 8. The previous term would be A sub 6. Those are the numbers that go along with it. Now, there's a generic format of this. And this is the part that you want to get. The current term is always called A sub n. This is like where you are right now. That's your starting spot, okay, in the generic form. The next term is always going to be called A sub n plus 1, right? If n is 7, the next term is 8, so it'd be n plus 1. So the previous term is always referred to as A sub n minus 1, all right? Box this part in. And this is your basically your generic. It works for anything. You can always use this to describe current, next, and previous. Your generic format. Okay? So you're getting that down right there. Boom, you got it. We're going to keep moving. I'm going to erase this with an eraser because those exist. Bong, bong. And you're just going to keep writing in your notebook all the stuff that you need. Hopefully we're going to keep this video under 10 minutes. And it'll be longer than most because I had to do a little explaining in the beginning because this is the first time that we did it. Sometimes I'll be silly, I might dance, make some jokes, you better laugh at your house, you know, all that good stuff, okay? So, we took that information that we had, now let's go right here. So, let's say we have a sequence. That multiplies. Six to the previous term. All right, so we have this sequence, and it always multiplies 6 to the previous term. So let's like lay out how we're going to think about this. So we have our previous term, we have our current term, and we have our next term. And again, you're getting all this in your notebook, right? Our previous, our current, and our next. Okay? So let's say our current term is 180. All right? What's the next term gonna be? If you always multiply 6 to the previous term, hopefully you just figured that out. You say, oh, I take 180 times 6, which I believe is 1,080. Okay? And that is because 180 times 6. That's how we got that term, right? Or we can look at it this way, times 6. Right? If it's always times 6, it would be whatever this is, times 6. So you should be able to figure out if we're going backwards, what would we do? Divided by 6, and this ends up being 30. Okay? So that's our terms, that's how they work. But now we want to say, well, how do we use the notations for them? Okay? But it's easy to start with actual numbers, all right? So we say, okay, well, what if I tell you this is a third term? This is the third term in this one, so this would be a sub 3. I'm telling you that, all right? This to you is given. I gave you this information. This is given. I've given you this information that it is a sub 3. They got to tell you that. So that didn't come out of nowhere. I'm just making it up. I'm giving you that information. Well, if a sub 3 is what this term is called, the next term, what do you think is going to be called? Oh, you thought about it, you're like, easy, Bass. A sub 4. So what's the previous term going to be called? Got this. This is nothing. A sub 2. Perfect, right? Before that one, after that one. And finally, we want to work into the spot where we talk about, all right, well, what is the generic term going to look like? Well, if this is our current, what did we say the current term? You should be able to look back up at your notes and be like, oh, we said the current term is always a sub n. So in this situation, a sub n would be our current term, which is 180, which is a to the third, right? The next term in this situation would be a sub n plus 1. We're talking generically. And the previous term would be a sub n minus 1. And again, right, well, if n is equal to 3, n plus 1, 3 plus 1 is equal to 4. N minus 1, if n equals 3, 3 minus 1 is equal to 2. For the a sub 2, a sub 3, and a sub 4. Okay? You're going to be working on this stuff in class, but this is just to kind of get your mind ready for that stuff. All right? All right, we got a little more to get. I'm going to erase this real quick so we can get on there. Appreciate you guys sticking with me. We do this here, and you're doing it at home, so you don't have to do it in class. So we can just come into class and do stuff and not just sit there and write notes when I'm going too fast for half of you, too slow for the other half of you, and it's just not that fun. I'd rather have you guys do this outside of here. All right? So this is the last part that we got to talk about to get you all ready for class tomorrow, which I believe is Friday, if it is the year 2018. I might use this in another year. In the future, might be different. All right? So there are 2 ways to write recursive rules. Okay? First way is when you say, okay, well, the next term equals. So this is where I start with, I want to know, well, what's the next term going to be? Well, I say, okay, I take my current term, and then I multiply it, or I use whatever operation to it. So I do the current term with the given operation. Okay? So an example of this would be a to the n plus 1 equals a to the n times 6. I'm using the exact same thing we talked about last time, right? Remember, a to the n plus 1 is your next term, right? And if you look back, you would see that was where our next term was. Next term equals a to the n is always current, and times 6 was our rule that we were using, right? So the next term in that last case was 1080 equals the current term, which was 180. Again, this should match with the notes that you took earlier, times 6, and that's true. 180 times 6 is 1080. This right here is a general recursive rule. Okay? But there's another way that you can write that rule. That's one way it works. But some of you might think about it another way. The other option is you can take, to get your current term, right? So in this one we talked about, well, how do I get the next term? And I started off from how to get the next term. This one is like, well, how do I get this current term? Well, to get the current term, I take the previous term, and with the given operation. With the given operation. Let me check, make sure I can see stuff. Okay? So in this case, I would take the current term, which we always know is called a sub n, and that equals the previous term, which we said is always a sub n minus 1, right? That's the previous term, times our operation, in this case times 6, because that was our rule. All right? So current equals previous with operation. Okay? So in this case, the current term was 180 equals the previous term, which was 30 times 6. All right? So you're getting that down. I know we're about 12 minutes in. This is the last piece. 15 minutes of homework ain't gonna kill you. Set you up for success. Be all ready for tomorrow. Okay, now tomorrow we just come in and do it. I'm gonna expect, oh, you did the notes, you made sense out of it, you thought about it, you're walking in, you're ready. You know why? Because you're an honor student. That's how you roll. Last thing you have to write. To be complete, a recursive rule should state the initial value. In other words, the starting point. Like, where does your rule start? What number does your rule start on? The initial value, this is usually shown as a sub 0. The initial value is usually called a sub 0, but sometimes they might tell you. They may use a sub 1. If it's not a sub 0, if it's a sub 1, they're gonna tell you about it, okay? So, this is your background. This is the stuff that's gonna have you ready for class tomorrow. Appreciate you guys doing this for the first time. Looking forward to this year. For Bass and Tillis, we out.